In example 17, we are having a function fx is equals to x squared minus 3x minus 10. And then part A, we are supposed to sketch fx. Sketch the graph of fx. Fx is simply this. And I would want to believe that there is some work to be done here, but we have done it before in a different video. So I'm assuming that in this one, you already know that the y-intercept is when x is equals to 0, and it's going to be negative 10. It's going to be something like this. Assuming this is negative 10, that is going to be the y-intercept. At the same time, we need to get the critical values of this graph or this function, and that can be realized either if you happen to solve this function using quadratic method, factorization method, or completing the square, or even graphically, you will get the critical values to be -2 and a +5. Those are the critical values. But of the most important is the nature of A, which is greater than 0, and of course the shape of the graph is a U. This one has been seen in a different video. So we have such a graph, and this is the graph of y is equals to the function of x. In part B of the same, we are expected to sketch the graph of y is equals to, yes, y is equals to the modulus of the function of x. Please remember that the modulus of the whole function does not allow any value of y to be negative. When you module the whole function, its solution will only be expected to be positive. So, in the previous video, we have seen that in such a scenario, we need to reflect the negative values of y along the x-axis. And this is just what we have. We have the graph of y is equals to fx. Now, this graph is going to be the -2 still maintains, and +5 still exists there, but it is -10 that is reflected along the x-axis to +10. So as much as you would want to have the graph now drawn differently, we must realize that it is the whole of this negative value or this negative region, all these negative values of y, that should be reflected along the x-axis all the way until 5, and you should be having a graph that looks like that. But after 5, the graph was positive before, and it continues to be positive after. And therefore, this is the graph of the modulus of the whole function. Remember, when the whole function is moduled, it means it has been absoluted, and we do not allow any negative values of y because of absolute fx. Part C, we are supposed to sketch the graph of y is equals to the function of x, the function of x moduled. Please remember that when we have such a graph, it is only the value of x that is moduled, only the value of x that is absolute. So we should know that in all cases, as much as we have the positive value of x moving from -10 all the way to 5, and this is 5. The reason why we have done that, the reason why we have considered only the positive value region, is because x itself is moduled. And when x is moduled, we consider each and every value of x to be positive. So we must consider the positive value of x when we are constructing y is equals to the function of x. But having done that, we have to remember one fact, that as much as x values are positive, we were having x values that are supposed to be negative. And whether we have x positive or x negative here, they are moduled. And that means this does not affect the value of y at all. Because whether we have x being 2 here or x being 5 here, when we have x being 5 here, we can see the value of y is 0. When we have x being negative 5, that negative 5 is moduled and it gives us the value of positive 5. That gives us the value of y, which was realized when x itself was 5. So we still maintain that the value of y is 0 when x is negative 5. Let us talk of a certain value like when x is probably like negative, like positive 2. You can see the value of y is a negative y. But if we put x to be negative 2 here, that means negative 2 itself is moduled to become 2, giving us the value of y negative. And when it is moduled to become 2, it gives us the same value of y. So we are going to have the same kind of graph reflected along the y-axis. And that is why, and if I might draw it a bit accurately, you will get the difference here, because this one just looks like this. I would want to be a bit clear. This is negative 10. I want to start from there, moving that way, so that the reflection will be seen. The reflection will be seen. It is actually along the y-axis. It's along the y-axis. But I've explained x moduled, whether x is negative or positive, we still get the same value of y. And that is why we have the reflection of x module along the y-axis. So that is as far as example 17 is concerned, and I hope you understand moving forward.